Hello, V. Welcome on stage.
Hi, Ming.
Yeah.
Welcome.
Let me share my slide.
Yes.
So can you see okay?
Yes. Yes. Okay. Thanks, sir. A quick intro. In his inaugural keynote, Dr. Gopal mentioned that in 2012, the containers did not exist. Now in 2020, 84% of enterprises adopted containers, and it is happening at a rapid pace. With this adoption, organizations are also seeing few challenges. Right? Enterprises are running their legacy workloads on the virtual machines, and they can't bring everything onto the containers. The ideal scenario would be coexistence of containers and the virtual machines. They would like to have a common technology and the platform to orchestrate both the virtual machines and the containers. So we have an exciting tutorial session, a simplified and converged platform for managing both VMs and containers to focus on this problem. We have Ming, the principal technologist from Redhat Singapore, to deliver this session. Ming is the product manager with Redhat focusing on the cloud infrastructure. She is based in Singapore and supports AP and Japan region. She works with the customers across the region, helping them leverage Red Hat technology to build the hybrid cloud solutions across physical, virtualized, and container platforms. She has also been working with the service providers adopting these technologies for the network function virtualization and has worked on multiple NFV proof of concepts and deployments across the regions. She has also been helping the network equipment providers in the APAC region on certifying the BNFs on the Red Hat stack. Ming also been working with the managed cloud provider to build the solution based on the Red Hat cloud infrastructure technologies. So before Red Hat, Ming worked with HP, and she has over 15 years of experience in industry working with OSS, next generation intelligent networks, converged networks, and NOC consolidation and the regulatory compliance. So with that, I request V to take over and deliver a tutorial session on this exciting topic. V, over to you.
Thanks a lot. So I actually come from the enterprise world. So I'm going to bring a perspective on how some of this technology, I think there's quite a lot of interesting technologies we discussed and how it apply and how we are actually helping enterprise customer with some of the adoption. So first of all, not sure how many of you are familiar with Redhat, but we are a open source company, and we have actually close to 17,000 employees worldwide. So the interesting thing about Redhat is that we are the first $3 billion company based on the open source model. So we have been taking quite a lot of the open source innovation and bringing that to enterprise customer. And if you look at where Redhat come from, it's really a long journey, more than 20 years. And we hit the 3 billion revenue mark last year, and after which we have been acquired by IBM. So then this year, we have a new president and CEO, which is Paul Cormier from our product team. So, but I think a lot of the question that we have in the industry as well as the community is how would Redhat evolve with the acquisition? But I think one of the assurance we have is that we are pretty much going to stay independent and focus on what we are doing, which is taking open source innovation to enterprise. So just a very quick overview on what we mean by it. And a lot of the technology that you're seeing today, be it in the management of virtual machine, be it the underlying RHEL operating system, or the next evolution on container management platform based on Kubernetes, all these actually come from open source community and collaboration from a lot of different parties. The reality is that with today's innovation and the pace of innovation that we are undergoing, is actually not very practical for us to sit and in an ivory tower looking at the requirement and then going through that and designing product. It is pretty much bottom driven. A user or group of user has a specific need. They collaborate, they come up with a solution, pretty much like conference like this or groups in different company who faces an issue and they collaborate to solve that problem. And so with those innovation that is occurring at different pocket within the open source community, Redhat brings all that together and deliver it to the enterprise customer in a consumable fashion. So the key technology that undermine virtualization and containerization come from different portion. And the operating system, of course, is a key part to make it a reality. And then we have the Kubernetes or platform, which come from the community and is being packaged into the Redhat Openshift platform, as well as quite a few virtualization piece and different options. So I go through how we get to that. So when we talk to enterprise customer, there is always a need to balance the optimization and the innovation. So today, if you look at how IT is evolving, we do not have an unlimited budget. The business competition is very steep. So you always need to look at the existing IT resources that you have and how you optimize and get to the best utilization. So a lot of time we are really looking at, for example, the session that we talk about scheduling and so on, is quite concerned about how you maximize the utilization of your resources. And virtualization and container are all technology to help you with a lot of these optimization and also utilization of the resources, and also driving into how you can make it easier for your folks to innovate on top of it. So one of the key advantage of container is that it allow a mindset shift towards microservices architecture, being able to decouple a lot of the programming logic into very small pieces. So if you look at where we are today, container technology exists for a long time, where we are doing like partitioning, where we are doing Linux container and so on, but it has never really taken off until we get to a stage whereby the Docker community came up with a proposition of having a standardized way of packaging a set of artifacts that make it portable and runnable across different platforms. And that lead to a whole movement and a whole community supporting that evolution and the adoption of container. But if we look at where we are evolving, we started pretty much with the bare metal evolution. We start to consolidate and drive innovation around virtual machine. And then the last few years, we see a lot of adoption with container, but it is still at the beginning. And from what we hear from enterprise, we need to have something that allows them to collaborate and manage all these infrastructure in the same platform. And ultimately, at the end of the day, when you look at the enterprise delivering value to their customer, they are not really looking at what the means of delivering it and where the application is running, but the end result that they are driving, which is the application. And so we want to shield them away from a lot of as much complexity as we can. And so if you look at the migration towards containerization, we are pretty much here where the virtual machine is still dominating the environment. But if you look at a lot of the growth that we're seeing from this point onwards to where we will be in the next 5 years, the expected growth in virtual machine is very small, maybe 2%. And a lot of time, the workload is really shifting towards the container portion. And of course, why move, right? One, the container align with a lot of the new mindset around DevOps, how you can decompose and allow better collaboration and different developer to work on their portion. And of course, you look at being able to shrink the footprint of your application, and the amount of optimization you're looking at is 10 to 100 times resource utilization between container and virtual machine. So there is a lot of advantage to move to container, but you're not going to get that in a single big leap. It's going to take a few iterations. And that's why we predict that at some point in time over the next 5 years, container will outpace virtual machine and become the dominant technology. But there is going to be a transition from where we are today with virtual machine into the container space. So if we look at where we are today, interestingly, when the IDC went out to survey folks that are already adopting container, and we see that in pockets within enterprise everywhere. And the thing is, very few of them are actually running container on bare metal. They are running container in a virtual environment. So, for example, if we look at our own customer install base, a lot of them are running container on premise on a virtual machine infrastructure or on public cloud like Azure, Amazon, and so on. Very few customer, I would say maybe less than 10, 15% install the container management system on bare metal and go about using just container platform to manage even the bare metal machine. So that's the mix that we are seeing today. But we do expect that over time, we will move to a more mature container platform that will be able to manage even the bare metal machine as well. So today I'm going to talk about the two options, the predominant option that we are seeing today, whereby we have seen customer deploying is in production and reaping advantage, and the new product that we have launched based on container and VM converging on using the container management platform as the dominant platform to manage the converged infrastructure. So maybe just let me set the stage a bit on the virtual machine management. So Openstack is really the foundation technology which has been around for quite a while, pre the Docker community. So we have like 10 years of Openstack community, and recently has been renamed to Open Infrastructure Foundation, simply because of the broadened scope. And Openstack, I think the last 4 or 5 years, we see a lot of folks actually adopting it predominantly in the telco industry, but we also see it in research institute, in banks and so on, as a large scale private cloud infrastructure. And if you look at a lot of the telco network today, a lot of them are using it to run virtual network function. And even in India, you would see that the big service provider like Airtel, Reliance, and so on, all Vodafone India, they are all embarking on setting out the virtual infrastructure on Openstack. And so we see Openstack as the key piece and help us to manage both the existing workload with the proven security, scaling, performance, and all that built in, and moving into the next era, which is the cloud native workload. So we are looking at it as the foundation piece and and a proven technology that help us to build this converged platform. So Redhat has been investing in Openstack for a very, very long time, and the current release that is Openstack 16, which we released sometime early this year. And one of the things that happened is that even though the Openstack community is on a very fast-paced release cycle, we do have Openstack 16 supported for 5 years. So yes, a very strong foundation for enterprise who wanted stability. And we are consolidating a lot of the innovation that we see on different version into 16 and having that set as a very strong baseline. And not only that, when the community upstream roll out new functionality and new feature, instead of releasing new major release, we actually incorporate that into 16. So you get a strong base, and then you still adopt and get the new feature set from the upstream community. So just to set the stage and ensure that we have a common understanding of what is OpenStack and what it does. So OpenStack was started like 10 years ago with a collaboration between NASA and Rackspace, the managed service provider, to really look at how you can have a public cloud-like capability within the data center, scaling to tens of thousands and hundred thousands of VM. And the key aim is actually to free the enterprise from vendor lock-in and collaborate so that we have a very high velocity of change going into it and a very high velocity of innovation. And of course, to be able to drive the efficiency in the infrastructure, we also see the need for a lot of automation, resource provisioning, scaling, how you run which type of resource where to maximize the investment in a private cloud environment. So it is really something that help you to manage the different resources within your data center, networking, compute, as well as storage to build that private cloud capability. And some of the highlight on what we are investing in and has released in the 16.1. One of the key asks and we have rolled out is to address edge use cases. So if you look at, for example, AI ML type of collection, a lot of time you do not want all the processing to happen after you send the data back to your central site. You want to distribute it, and you want some of the computing resources to live as close to the user as possible. And in fact, when you are looking at some of the collaboration around like connected car, you want it to be connected to edge site with very low latency instead of taking the latency hit on moving everything back to your central site, and then processing the request and putting out the request back to the edge or the customer devices. So this distributed compute node architecture allow us to run only compute node at the edge site, leaning the footprint. And then, of course, very importantly, is how we do monitoring, analytic, and so on at a lot of these edge site. And then right now, what we have is that we could have multiple clusters set up, but and each of them is about 700 nodes. But with the massive scale that we are looking at right now, there is a lot of ask to scale beyond 1,000 or more, and we are having that ability to scale beyond 700 node limit that we are seeing right now into 1,000 or 2,000 nodes per cluster, so that you have a same single control plane that can control and distribute your VM provisioning to more than 1,000 or 2,000 nodes within your infrastructure. And this is where we are. So it is actually a collaboration project that has been started, and we are seeing a lot of collaboration between different companies. So as of 2019, we have about 20% of the total contribution, with the rest quite equally spread across multiple vendors, and we're still one of the key contributors to Openstack community. And if you look at the life cycle, we have the life cycle stretch beyond 2026 based on different version of the upstream community. And quite interestingly, after our Openstack 16, we are no longer doing like an interim release of 1 year. Each version will be supported for a 5 years period to provide that stability that enterprise customer need. And that also attests to the fact that Openstack has stabilized quite a lot, and we are not really moving version every year at the moment. But in between, we will do a lot of dot release and incorporate new feature and through the dot release version while keeping the stable base that you need. So of course, RHEL 8, a lot of you probably have heard about the launch of RHEL 8, our new version, and this is bringing the new innovation and like how we can support AI ML through GPU, vGPU, better load balancing across them. And this actually is the foundation that we are building our Openstack 16 on. So then shifting the gear a bit on onto container itself. So if we look at container, the biggest issue we have when we have so many container out there and deploying it for enterprise customer is how do we orchestrate and manage the container across the environment. And Kubernetes is evolving as the container management platform of choice for most of the customer. So initially there was a lot of different container management tools like Miso, Swarm, and so on. And now I think the community is converging on the Kubernetes as the container management platform. But the thing is, Kubernetes alone is not sufficient. You still need a storage portion. You need the container itself. You need a registry. You need a management framework, a monitoring framework, and so on. So the Redhat has taken the innovation and the Kubernetes software packages from upstream, package it into something that a enterprise customer can consume. And this is how we have built the Openshift product. And it contains hundreds of defects and performance fixes that we are rolling upstream. It has an ecosystem of partner that we are working with to ensure that when you are deploying a workload, you can be assured that the workload will run because it has been tested by the vendor who is providing that piece of application, as well as Redhat on the Openshift platform. And we are able to do all this work because we have been contributing alongside with other folks like Google since day one. So we are like the number 2 contributor just behind Google on the total contribution to Kubernetes community at the moment. Okay, and so let me go back a bit. So if you look at the Openshift platform, it has a few layers. So we have the Linux operating system, which allows Openshift to be installed and run on multiple platforms, be it physical, virtual, private, public, or even at the edge side. And then on top of it is Kubernetes, which is the orchestration layer. And then we have all the services on top of it that manage how the container is deployed, is run, monitored, and controlling the integration to the underlying networking and storage piece. So these are all the clustered service on top of it. And this portion is what we call the OpenShift Kubernetes engine. And on top of that, we have platform services that make it easier for developer to build on top of it, like CI/CD pipeline management, service mesh, and then we have the application services like different runtime, and then we have data services, and as well as integration to IDE. We provide a cloud-like IDE using code ready, and also integration into the local developer sandboxes. So these together, these make up our OpenShift container platform, and we can manage multiple OpenShift cluster using a cluster management solution on top of it, which is the advanced cluster management. So we have the virtual machine management piece, and then we have the OpenShift piece. So now we try to tie the two together into a single platform. And this is how we do it using OpenShift 4 and Openstack 16.1. So with the Openstack and OpenShift, what we do is that we are doing a full stack automation. So when you provision OpenShift on top of OpenStack, you can do a single installation. It set everything up, including creating the VM image that is needed on OpenStack, provision it, configure it, and so on. And with the OpenShift 4.4, we put it even further to allow customization of the underlying resources, so it can support pre-existing infrastructure that the user has provisioned and tied to certain external component on OpenStack. So both are supported in the current architecture now. And so if you look at how this is being set up, the installer and the lifecycle manager will actually set up the network, the load balancer, and all the instances, including the operating system for nodes and so on. So this is a full stack automation that has exists. And then with UPI, you can extend it by having different resources customized. So these together with what we are seeing on the DCN, we actually allow these to be distributed and across the different architecture. And if you look at the DCN architecture, you have the different edge site. So you could actually control from the central site a multiple deployment of cluster just using a single control plane on the central site itself. And so just want to reiterate some of the commitment that we are looking at. We are still putting up a lot of innovation into Openstack, tightening the integration between the two beyond 2027. So this Openstack on and Openshift integration is now one of the predominant way that folks have been running it in production to get to a converged platform. And I just want to go through a short demo of how this actually look like in action and how you scale the resource for container when it's running on Openshift. One of my colleagues has actually done the recording of this, so I'm probably just going to play it back.
We have two recordings received from you. One is on OpenShift and another is on Windows Server 2019. Which one would you like to play?
The first one, the scaling of Openshift on Openstack.
Okay. Yeah, I'll play that.
So I will stop sharing and let you play the recording.
Thank you for joining me for this demo. This is a demo about Openshift on Openstack auto-scaling. To do this, we deployed an Openshift 4.3 environment. We used full stack automation as our method of deployment. You might know this as IPI. This is great because it gives us the 6 nodes, 3 masters, 3 workers, very easily. These nodes are all actually deployed onto Openstack using a dedicated tenant. This is really cool because the Openshift installer creates the Openstack instances directly for us. We can see them here in Horizon, but it does more. It also builds the networking and everything else you need to get a working Openshift install. So let's see how Openshift sees this. Here we've got our nodes, the 3 masters and the 3 workers. These nodes are represented as machines. It's the usual install. We also get a single machine set for the workers, and that's important because that's what we need to go ahead and scale our cluster. Let's start by creating a cluster autoscaler. You only set one of these, and as it says, it governs the whole cluster. It's easy to edit. You can do it right in the console, and this controls the global settings for the entire cluster. Then we need a machine autoscaler to scale the machine set for the workers. This was the same machine set that was created at installation. So you can see the worker up there, and we are able to create some limits for this. So we have a max of 8 and a minimum of 1, meaning there must always be 1 and a replica. So a minimum of 2 workers, which is actually less than the number of workers we deployed. That's really it. So it's time to give it a try and scale Openshift on Openstack. Of course, to scale, we need load. So we're going to do this in a unique project. So we created an autoscale example project for our testing. And we'll use that project to run a special job that generates a lot of high load by creating a lot of busy pods. In this case, we're going to just bring up a pod that uses up a gig of memory. We're going to run 84 of them. They're going to run in parallel, and then they're going to die off after 5 minutes. And that means that once complete, the pods will terminate to allow us to see a scale down as well. So as you can see, we don't have any pods running. We are in our special project, no pods running. We need to generate this load. So let's run the scale job. So we run that job that you just saw. Off it goes. And then we can go ahead and look again at the pods. And look at that. We've got 84 load generating pods being created. So let's see how that's affecting Openstack. Instantly, the machine set autoscaler is requiring more nodes. So we're looking at an Openstack view and we're seeing Openstack instances get created. Workers are being built in the underlying infrastructure as a reaction to that. And then we can see this in Openshift as well. Have a look at the machines and we see more. They're building, they're provisioning, and they're growing. So as the load continues to increase, the machine set continues to grow the machines up into the limits that we set. Here we go. More OpenStack instances are being created. Our 84 jobs are going nuts. They're really covering everything. Back in OpenShift, the process continues. And as you see here, they're provisioning, they're building, and they're matching in naming. So the naming is consistent across platforms. There's no difference. You can see that Openshift is talking to OpenStack. These are the same instances. The infrastructure is scaling. Our usage is going up. This is Horizon from OpenStack showing vCPU up. We've got more workers. We're scaling. We have many, many instances. But of course, all good things come to an end, and the scaling job ends. So it begins to remove nodes from the machine set. It disables them. It takes them out of circulation. Remember, our jobs are terminating. There they go, disappearing. The nodes are going away. The machines are going away. Same thing's happening in OpenStack. The instances, of course, the same instances, are also being removed. So the OpenStack administrator is seeing it. The OpenShift administrator is seeing it. We can track this process across the platforms. Again, we see a worker instance in OpenStack. Then it's gone. And then the system returns to the state that the autoscaler wants it to be in. We deployed with 3 worker nodes. We now have 2 to match the replica set request we made. And then we have a total of 5 nodes. And eventually everything settles and we're done. That's it. That's OpenShift on OpenStack autoscaling. Thanks for watching.
Yeah, that's all, Hwee.
Thanks. So hopefully this gives you an idea on how you can have the shift on stack solution, the OpenStack managing the physical infrastructure, and the OpenShift is managing all the container and the application that's running on top of it. And this infrastructure is shared with other users who might be running VM on top of Stack. And when OpenShift need more resources, as you can see, when we scale up the workload on OpenShift, it will, through the integration, spin up more OpenShift node and allow you to expand the capacity of OpenShift. And once the work is completed and you do not need that much resources, then it will allow you to scale back and free up the resources for other users who might be using the infrastructure to run virtual machine. So that's the technology that is quite matured and in a lot of the production side today. I'm now going to switch gear to talk about how we can have a second set of technology, which is Kubernetes driven, and how we evolve into that. So let me just take over the screen sharing. Would you be able to let me share my screen?
Sure.
I think you probably have to let me.
You need to release the screen.
Yeah. Because I can't share it right now. Okay.
Yeah. Now you go.
Okay. So the other set of technology which we have been building out and we just went GA is Openshift Virtualization. So we kind of flip that the paradigm a bit. whereby now we are having Openshift as the platform that manages both virtual machine and container instead of the shift on stack technology that we are seeing today. So if you look at the evolution, one of the reasons why we are releasing a Openshift virtualization as an option is because we see a lot of the enterprise customer being split in the sense that they want to modernize, they want to get to container, but it's taking quite long, and a lot of the VM is still existing in their environment, and they can't actually get rid of the VM. They have solution like the virtual machine and container coexisting on platform like shift on stack, but they're looking at something that is simpler to manage, and also having it driven by the next generation innovation like Kubernetes, so that virtual machine itself can leverage some of the platform services. And platform services are things like the CI/CD pipeline generation, the networking backend that the Kubernetes platform provide using like service mesh and so on, that you will have issue if you are not having Kubernetes as the management system across two technology. So what Openshift Vert try to do is to support this set of customer who see the future set as Kubernetes as the predominant management platform. And this allow them to use Openshift Container Platform to manage the bare metal machine. And it helps the customer to converge into this new platform whereby predominantly they want container, but they have a few VM that they need to manage. And this typically we see in innovation center or folks that are really looking at next generation type of infrastructure. So these actually look about how the virtual machine and container can coexist from an application point of view, whereby these actually make up application, and the application share the same underlying backend infrastructure. And usually what we see a lot is that the developer team, they are building on top of the container management platform, and they have a set of VM, maybe some running their database and so on, that they cannot modernize, and they leave it and shift it so that they will share the same set of management function as the newer container platform. So the one of the key differences, the shift on stack look at it from infra ops point of view, managing both together, whereas Openshift Vert look on from the innovation and the newer application building, which needs some support for a set of VM. And the guiding principle around Openshift virtualization is that instead of having the container live in VM, we are having VM live in a pod structure, which is the container structure, and consuming the resources provided by Kubernetes based on the policy that's set in Kubernetes. And there is dedicated API because customer would still need to manage some of the VM specific attribute and VM lifecycle. So we have dedicated API so that you can still manage some VM specific attribute. But the guiding principle is that we will have a Kubernetes native first approach. So everything will need to fit into the Kubernetes framework on how the resource is being managed, and issue around how you use the virtualization feature, it will be solved in a Kubernetes native way. And so for application developer, it's very cool because it provides them with a consistent developer experience across VM and container. And some even extend it further to serverless. So there is a unified tool set that allow them to access all. And we are actually converging on like pipeline CI/CD for both VM and container on the Openshift platform. And one of the key asks or use case that we see when we look at this is that Windows application, we can actually move Windows application to Linux or to container, but the reality is that it's actually quite challenging to do it. A lot of the container technology is Linux based, and they wouldn't want to refactor their Windows application into container and so on. So these Openshift Vert actually allow them to run it side by side using the same underlying infrastructure and platform. And these allow you to shift everything onto Openshift platform, then slowly refactor some of the application as and when you see need. But it allow you to take the lead and onboard onto Openshift right from the beginning. So from the infra owner side, it also provide quite a lot of experience, advantage in terms of the consistency in management, and you focus your attention on the management of the infrastructure, on the maintaining the platform and infrastructure, and a lot of this is actually automated and hidden in terms of security and so on that is inherited from the KVM perspective. So I will go a bit more into that. But just to look at how the technology have evolved, it's not really something that started in the last few months. It actually take quite a while for us to mature the technology. And from the first version of Openshift in 2015, and we test out the KubeVirt capability about 3 years back. And then we demo and recruited quite a lot of pilot customer, and to the state that we are actually ready to roll it out just this year. So it's quite a long journey to get to where we are. But even then, we are still looking at targeted use cases, not general use case whereby you want to replace Shift on Stack, for example, with Openshift Vert. It has to have a business reason and looking at the use case that you need to address. And when we look at extending Openshift with the virtualization capability, the interesting thing is fit within the whole framework quite nicely, and that is intentional. So where you see Openshift virtualization is just this little piece as one of the clustered services.
Looks like we lost a Hwee.
We lost that. Let's give a minute.
Yeah.
Yeah. Yeah, so
Hey.
yeah, she's back now. Good.
Yeah, I'm not sure got disconnected for a while.
Yeah, just a 1 minute disruption was there. Please.
Oh, okay. Yep, I think you can see my screen, right?
Yes.
Okay, yep. So I think we're back. So just I was saying, this actually is a very smooth extension of the whole OpenShift platform, so that with the OpenShift platform, you are able to leverage all the other great things on the platform, like the platform services, the application services, even the cluster management services, by having virtualization as a small piece within the clustered services and provide the new functionality that is needed. So then I'm taking it forward. What we see is that these allow you to do a mix of application, traditional cloud native, but it also allows the VM to coexist with the next generation workload that we're seeing. And a lot is around serverless and driven by AI, ML, event driven workload, and so on and so forth. So OpenShift then for the customer become the platform that allow you to manage VM, container, serverless using the same consistent set of functionality. And when we look at virtualization and trying to feed it into a container management platform, there are quite a lot of constraints and things that we need to overcome. And one is virtualization means that you virtualize the underlying resources like compute network and storage. And if OpenShift has been relying on underlying VM solution to do that, then we need the OpenShift platform to understand these resource management constraint. You need to be able to schedule the VM and provide things like HA, live migration, configuration management of the VM itself. So you need to be able to extend your platform to cater for a lot of that. And so when we look at a comparison between some of the technology, we have RHEL, and we also have OpenShift Vert, and we have different technology that does that. And one thing in OpenShift virtualization is that we rely a lot on the native interface within Kubernetes to get that awareness. So, for example, like network awareness is done through the container native interface provided by Kubernetes. CSI, which is a container storage interface provided by Kubernetes, allow us to extend the awareness to the storage portion. And the main, yep.
I think we need to conclude in 10 minutes. So please plan accordingly. Yeah.
Yep. Okay. I will try to.
Yeah, you have.
I will try to go through it a bit quickly on some of the stuff. And so some of the key difference and what we have done to lead to the containerization area is that we have really packaged some of the key components that you see on traditional virtualization technology like OpenStack, the pieces that is there today, libvirt, KVM, we package that into a KubeVirt container and have it run on top of the OpenShift platform and communicate to the OpenShift console through a kubelet. And so we look at these actually coexisting with the existing OpenStack platform to ensure that there is a smooth transition whereby the same KVM technology that is running in Openstack is also being leveraged and used in the OpenShift virtualization. So the virtualization technology is common across all the different technology. The only difference is how it is being managed and integrated into the OpenShift platform. And these technology, we have been working with some of our early adopter, and this is a
Looks like again we have a network disconnection. Hi, Hwee. Welcome back.
Yeah. Okay, I was just talking about this customer that we have been working with. It's a global investment bank, and they are running almost 40,000 workload, and we're using the technology to help them with the virtualization. And interestingly, this is a customer who is moving from a legacy ESXi based hypervisor into the new technology. So just want to look at a quick difference between that, and I'm sure a lot of you probably are familiar with. The virtual machine traditionally managed and packaged together is gas operating system running on top of its hypervisor. But this layer is stripped off when you are moving into container. And so we need to ensure that there's a strong base in terms of how you do the container orchestration. So when we put VM into container, we are really putting in these set of resource management and system processes around KVM into a container.
It happened again.
Yeah, I think we'll have again 1 more minute. I think she should be back. So just an announcement that third research scholar presentation we'll be having after this. So please hang on and give him good inputs.
Well, be back.
Hey, sorry, I think there's a lot of disruption. So I just try to wrap up and give you a intro on what we're trying to do. And so what it does is that it package all the KVM capability and allow you to use that and treat the KVM portion pretty much like a container on top of that. And the nice thing is with the cross certification, you can also use the same framework to run the Windows workload on top of it. So I think I would want to leave you with a short demo on how you actually onboard a Windows VM onto the platform. So I would hand it over to the host to go through that demo video on how we can run the workload, Windows workload on Openshift Virtualization using a single management plane.
Shashi.
Yeah, I'm playing that.
Yeah, I have a question. Is it okay to ask? Dr. Rambabu?
Yeah, please go ahead, sir.
Good afternoon, Hwee. It's a nice presentation. I really appreciate the landscape that you presented in a few moments because it's very difficult to get the big picture of what Red Hat has to offer. I have a question which is in two parts. Part one is, do you have interoperability support? And to what extent is it available with other cloud vendor offerings? That is part one. Part two is for small businesses. While Red Hat is typically very famous and well-known, reputed name in the world of enterprises, what do you all have for small businesses? And how do you compare yourself with, say, DigitalOcean or Linode or such?
So we do have a partnership with folks like Amazon, Azure, and so on. So if let's say you are a small business is starting to embark and you do not want to invest in your own infrastructure, you can get OpenShift through Amazon or Azure from their offering, and is fully managed and supported on the public cloud resources as well. And we are also working with them, and this should be available at some point in time, whereby they will allow us to manage bare metal node on public cloud resources like Amazon and so on. And you can have both OpenShift and the OpenShift Vert capability on public cloud. So we are actually providing a lot of options for our customer. And of course, if let's say you are a university or a school which you have a lot of developer resources and so on, and you want to run a community version, we also have a community version upstream that is available, and you can download and install it without any charges on your system. And we also encourage a lot of collaboration at the community level. So there are a lot of different options that we are providing as well.
Shall I?
Sorry, what do you have to say about the DigitalOcean offerings and Linode offerings, and how does Red Hat work in that space?
Pardon? You mean the competitive product offering, or?
Yeah, exactly.
Yeah,
DigitalOcean
okay.
has its own cloud offerings, and many people, especially in the small businesses, go to DigitalOcean. So does Linode, Linode. So I was just curious as to what you all have as a view of these offerings.
So there is a lot of offering which is quite fragmented. But what we see is that the small business, when they are looking at scalability, they want to start small, but plan to have a platform that allow them to scale into as they mature and get to a larger enterprise. So they, when we are looking at Red Hat or some or offering for Red Hat on Amazon, it actually allow a lot of these flexibility. So even the early days when we are looking at like OpenStack, there are a lot of competing smaller offering, but they do not actually get to a maturity. A lot of them got merged or got acquired. So when you're starting out looking at a new technology, it might be tempting to look at a very niche solution, but really how you scale your business and how you have an enterprise partner that you can work with in a longer term, that will be one of the key considerations. And one of our value proposition is that we understand the open source community. Our product has a very long life cycle, and we have partnership with a lot of ecosystem partner that ensure that you have that ecosystem support when you need to. And if you are part of the ecosystem, you could actually leverage a lot of the size and skill and the stability that we have to offer. So that was one of the value proposition that we have over the competing solution.
I think, Shashi, in the interest of
Okay,
time.
thank you, Dr. Hwee.
No problem. If you have any further question, you can just drop me an email or something like that, and we can connect offline.
Sure. I will get in touch with you.
Yep.
Yeah, please. Shall we play another video? Rambo, you were saying something?
Dr. Sanjay, how much time do we have?
Let me check. Yeah, we have time till 11, including question answers. Yeah, so we do have time.
Yeah, this video takes around 4 minutes.
Yeah, I think we can play.
Okay, please go ahead.
Yeah.
This video will show the process of creating a Windows Server 2019 virtual machine using Openshift Virtualization. We will start with our Openshift cluster. This cluster is relatively small with a few other containerized and virtualized workloads running. Here we see a containerized guestbook application, a quaint relic of a bygone time using Redis and PHP. Moving to the NCC1701A namespace, we see there are some other virtual machines already running. The pods we see here represent the libvirt, QEMU, and other container-based technologies being used to instantiate and manage our virtual machines. Moving to the virtual machines view, we get a more concise perspective of the virtual machines. If we were to look at the options for these by clicking the three dots on the right side, currently highlighted, we would see operations like start, stop, and delete for the virtual machines, standard management capabilities. Because Openshift Virtualization is Kubernetes-based, we have the option of defining the virtual machines using YAML. However, to illustrate the process, we will use the wizard for our Windows Server virtual machine. The first question asked by the wizard is the source of the virtual machine. The options here are to create a VM with no disk for PXE booting, use a URL to import a disk to a new volume, use a container image for the disk, or attach a new or existing PVC to the VM. For this demonstration, I'm going to select disk. We will do this to use a pre-existing PVC, which has been pre-staged with the Windows operating system in order to save time. You can see a significantly accelerated version of importing the 40 GB disk on the screen now. I'll pause briefly to highlight that this disk is being imported from a KVM-ready Windows image, which was created for Openstack. The process is straightforward, relying on the standard Kubernetes persistent storage paradigm of persistent volume claims to request storage, which is then met by a storage class. With the source defined, we tell Openshift Virtualization which operating system we're using. I'm choosing to use a predefined virtual machine size of medium, which represents 2 vCPUs and 8 GB of RAM. This is a server workload, so we want to be sure to set the profile correctly. And last, for this screen, we will set the host name. The next screen of the wizard will ask us what network we want to connect to. Here we will select the administrator-defined external network for VLAN 14, which uses Multis to create the resources on each of the Openshift nodes and connect the pods to an external network. The final step is to attach the pre-allocated disk. As with any other Kubernetes pod needing persistence, the disk is defined as a PVC with a storage class associated for dynamic provisioning. For Linux-based operating systems, we have the option of providing cloud init configuration here. We won't use this with our Windows virtual machine, however. With the virtual machine defined and created, we're ready to turn it on. The details for a powered-off virtual machine are not terribly interesting, so we'll use the menu to power on the VM. After a few moments to create the virtual machine instance pod and allow Kubernetes to schedule it, we see the VM go from starting to running. At this point, we can use the built-in viewer to see the virtual machine console and wait for it to boot. After Windows has successfully booted, we can hand off to the security team for them to take ownership and deploy the application. Since this VM is connected directly to an external network, no Kubernetes service or OpenShift route needs to be defined to enable access. I hope this introduction to creating virtual machines with Openshift Virtualization has provided a provocative peek into what's to come. Thank you.
Thank you. So we have a few questions coming up from the question window. VMs in the pods, is there any performance limits by doing this when compared to the normal VMs? This is a question from Steve.
Yep. So if we look at the overhead that container introduced, the container actually introduced very minimum resource utilization compared to VM. So you are not really talking about any significant differences when you are running VM in pods. The only issue that we are seeing are things like if you want to do a vGPU on your VM, and then the GPU has to be connected through the Kubernetes platform. So there will be a constraint when you're looking at performance sensitive workload that rely on hardware acceleration technology, because you have a layer that is shielded by the Kubernetes infrastructure. But in terms of the actual performance overhead, it's not that significant overhead.
Okay, thank you. And there is another question: what are the competitive products for OpenShift virtualization?
So what we're seeing right now is that we are seeing the more aggressive offering from VMware around Tanzu. A lot of folks probably would have heard about it, whereby they are also offering a similar product suite, but they are more VM heavy, whereby Redhat actually come more from the Kubernetes as the unifying platform. So the key difference is, if you look at Shift on Stack, is a more traditional offering, whereby is VM heavy. But then Openshift Vert is very Kubernetes heavy, as in you see Kubernetes as the unifying platform, and the platform you want to have the management and orchestration capability on, then you add VM to it, which is quite a slightly different view from what traditional virtualization vendor have. And we're also seeing folks going upstream. So Redhat, as an open source company, we do not have anything that we are keeping in-house in terms of source code and all that. Everything is contributed back to the upstream community. So we do see folks who are using upstream directly, or small niche company that take the upstream code and package it themselves and having a DIY type of model. So those are some of the competitive type of offering that we are seeing today.
Okay. Thank you, Hwee. Very interesting session. Running containers and VMs side by side is really an interesting topic, and organizations are looking for. You provided the idea of the open source and the Red Hat contributions to open source, and how the containers are going to grow in the future, right? And the necessity of running containers and virtual machines side by side. Thank you for insightful session. I really appreciate. Thank you.
No problem. One last thing, if you want to try out some of the things, there is a trial that you can use at try.openshift.com. So if you want to, you can try it out.
Okay.
I think that's all we have. That's all I have. Thanks so much for your time.
Thank you so much.
Thank you. We now end this session.